Myself, Dr. Prashant Kumar Bardhan, Professor, Department of Mechanical Engineering, GIS College of Engineering, Kollani. My subject topic is Advanced Welding Technology, ME 703A. Course objective: after completion of this course, all students will meet the following objectives. Number one, to impart knowledge on various advanced welding processes so that the student can apply them in engineering industry applications. Number two, to develop the knowledge on the design of welded joint and the quality control of weldments. Course outcome: upon completion of this course, the student will be able to achieve deeper knowledge of welding materials and technology of welding, deeper knowledge of different metals and their properties in welded construction, knowledge of quality technique at production by welding, knowledge of current computer robotic system, and cost for welding operations. Advanced Welding Technology, ME 703A, is a seven modules. Module 1, Introduction, Review of Welding Processes, and Joint Design of Weldments. Module 2, Process of Fusion Welding, Arc Welding, Sealed Metal Arc Welding, Gas Metal Arc Welding, Submerged Arc Welding. Module 3, Solid State Welding Processes, Pressure Welding. Module 4, Friction Welding, Electron Beam Welding, Ultrasonic Welding. Module 5, Gas Tungsten Arc Welding, Plasma Arc Welding, Arc Welding Equipments, Electrode Selections. Module 6, Welding Metallurgy, Heat Effective to enhance weldability of plain carbon steel, stainless steel, cast iron, aluminum. Module 7, Welding Defects, Types, Causes, Inspection, Remedial Measures, Testing of metals, testing of welded joints by visual, die penetration, radiography, ultrasonography, and safe practices in welding. Prerequisites: manufacturing technology, welding technology, joining of metals. CO mapping. There are 12 POs and 4 COs. 4 COs against 12 POs. That this is the one. 3 is the maximum, and 1 is the minimum. This is the average figure, average of POs against the CO. This is the average figure. Advanced Welding Technology, ME 703A. Today's lecture is Welding Defects by myself, Dr. Prashant Kumar Bardhan, Professor, Department of Mechanical Engineering, GIS College of Engineering, Kollani. The weld, the weakest point of metal construction. Why the reason? Welded seam is weakest point of metal construction. Number 1, welding defects, wrong sequence of welding, welding stresses, welding deformation, base material overheating, characteristic of material variation. Welding defects. Damage usually starts from the area of welded seam. Weaknesses of welding seam is a result of welding defects. That is very weaknesses of welding seam is a result of welding defects. A weld which is made the correct way is as strong and as hard as other parts of the metal product. So we'll discuss about the welding defects and how to rectify that in the next slides. That is slack inclusions, low amperage causes low amperage, improper technique, slow travel rate, precautions, preventions, increase amperage, increase travel state, repair removed by grinding or other mechanical properties. Slack may be included maybe due to low amperage, slack may be inside the weld mill. So it has to be removed by grinding and the repair can be done. Type of other defects, slack inclusions, undercut, porosity, incomplete fusion, overlap, underlap, underfill, spatter, excessive convexity, excessive reinforcement, incomplete penetration, excessive penetration. This is undercut. Because high temperature undercut is a undercut. This portion is undercut. High amperage, wrong electrode angle, long arc length, and rust. Prevention, set machine on scrap metal to correct the parameters, clean metal before welding. Repair, weld with smaller electrode, sometimes must be low hydrogen with heat. This is the undercut. This is portion is called undercut. Porosity. When the welding is performed, then there are so many gases are try to enter in the welding area. So after cooling, the gases try to escape from the weld area. This is the try to gases. So Pinot's porosity occurs. So we have to cover the environment and this welding arc with covered uh, inert gas, covered with inert gas or other protective fluxes so that no oxygen, no hydrogen can entrap in the liquid metal. Incomplete fusion. This is incomplete fusion. This is incomplete fusion. Cause low amperage, steep electrode angle, fast travel speed, short arc gap, lack of preheat, electrode too small, unclean base metal, arc of seam, preventions, eliminate the potential causes, repair, remove and re-weld, being careful to completely remove the defective area. So defective area should be removed and then re-weld. This is the incomplete fusion. So defective area should be clean and then re-weld with proper precautions. Incomplete fusion, incomplete fusion. This is L joint, and this is butt joint. Overlap. This is overlap. So this is overlap. This is overlap. Cause improper welding technique, steep electrode angle, fast travel speed. Precautions. Overlap is a contour problem. Proper welding technique will prevent this problem. Overlap. Underfill. This is the underfill. It's not properly filled actually. Improper welding technique. Prevention, apply proper welding technique for the weld type and position. Use steeper bead before cover pass. Repair simply weld to fill may require preparation by grinding. So initially grinding, then fill up with proper welding. Spatter cause high arc power, magnetic arc low, damp electrode. The spatter is mostly because of the damp electrode type, low grade electrode, and high arc magnetic arc low. Prevention, reduce arc power, reduce arc length, and also use dry electrode so that moisture creates a spatter. Repair, remove by mechanical process. This is the spatter. This is a spatter. This can be removed by grinding. Okay. Mechanical process. Excessive convexity. This is excessive convexity. So this is to be removed. Cause amperage and travel speed. If travel speed is slow, then uh, it may convexity is prevention, observe proper parameters and technique. Repair must blend smoothly into the base metal. Excessive concavity. This is a concavity. This is concavity. So amperage and travel speed causes travel speed and amperage. Prevention, observe proper parameters and techniques. Repair must blend smoothly into the base metal. Excessive weld reinforcement. Cause this is excessive reinforcement. This is the dotted line. This is the excessive portion. This is the excessive portion. Travel speed too slow, amperage too low. Prevention, set travel speed and amperage on scrap plate. Repair, remove excessive reinforcement and feather the weld toe into a smooth transition to the base plate. Root reinforcement. This is the root reinforcement. Face reinforcement. Incomplete penetration. This penetration is incomplete. This is incomplete penetration. Weld metal not entered in the bottom portion. Root. So root is very important. Causes low amperage, low preheat, tight root opening, fast travel speed, short arc length. And deep penetration electrode or deep penetration welding is also required. Arc amperage should be increased. Correct the contributing factors, repair back gouge and back weld. Excessive penetration. This is the penetration. This portion is excessive portion, excess penetration. Penetration width. This is the width. And this is also the top portion also is excessive. Crack, cracks caused by thermostasis. Catar crack, A is catar crack. This is a crack. This is also crack. This crack is portion is so weld. This is small hair cracks. There is also various types of cracks in butt and T joints. The kicks, crack, toe crack, under under bead crack, longitudinal crack, this longitudinal crack, transverse crack, this is transverse crack. So many cracks can develop, cracks caused by thermal stasis, basically. So basically, thermal stasis, cooling or preheating is not done properly, and cooling also. This is toe crack. This is toe crack, toe. This is longitudinal crack. This is longitudinal crack. This is base metal, the welding, crater crack, crater crack, crater crack. Magnetic blow. Why magnetic field caused the arc to deviate from its intended course. What to do? Use steel block to alter magnetic path around the arc. Number two, divide the ground into part. Number three, weld in same directions the arc blows. Four, use a short arc. Number five, locate the ground properly on the work. Use AC welding. So magnetic blow, steel block to alter magnetic path around the arc. Divide the ground into parts. This is the magnetic blow due to this scab. Welding is not done properly. weld stresses. Faulty welds, faulty sequence, rigid joints. What to do? Allow parts to move freely as long as practical. Make as few passes as possible. Pin deposit. Anneal according to thickness of weld. Move parts slightly in welding to reduce stresses. Wrapping. Why? Shrinkage of weld metal, faulty clamping of parts, faulty preparation, overheating at joints. This is due to sink wrapping. It is basically due to stresses and excessive heat. What to do? Pin joint edge before welding. Weld rapidly. Avoid excessive space between parts. Clamp parts properly, back up to cool. Adopt a welding procedure. Distortion. Why? Uneven heat, improper sequence. What to do? Track or clamp parts properly. Track, tack and clamp parts properly. Form parts before welding. Dispose of rolling or forming stains before welding. Distribute welding to prevent uneven heating. Examine structure and develop a sequence. Tack or clamp parts properly. Form parts before welding. Dispose of rolling or forming stains before welding. Distribute welding to protect uneven heating. Examine structure and develop a sequence. Brittle weld. Why? Wrong electrode, faulty preheating, metal hardened by air. What to do? Preheat at 135 to 260 degrees centigrade if welding on medium carbon steel or certain alloy steel. Make multiple layer welds. Anneal after welding. Use stainless or low hydrogen electrode for increasing weld ductility. So brittle weld is preheat at 135 to 260 if welding on medium carbon steel or certain alloy steel. Make multiple layer welds. Anneal after welding. So must be heat treated. Use stainless or low hydrogen electrodes for increasing weld ductility. So brittle weld. Precautions, how to eliminate welding seam faults. Careful and faultless welding work. Correct filler material selection. Use the correct welding parameters and welding technique. Work according to the WPS, welding procedure specification. Designing welding design engineer should prepare the WPS so faultless welding can be done. Follow the manufacturer's instruction and recommendations. Follow the heat input recommendation. That also manufacturer given in the electrode box. They recommended the heat input for impact, ductility, and strength. That we have to follow this. So precautions we have to take so that faulty welding can be minimized. So this is the end of this. Thank you. Thank you very much. Welding defects we have discussed.